Welcome to this explainer. We all know we need to eat, right? But how often do we actually stop to ask what's happening on a microscopic level when we do? Well, today we're completely demystifying macronutrients. We're going to uncover the molecular why behind the fuel your body uses every single day.
Okay, let's dive into this. Here is our roadmap for today. First, we'll meet the 3 macronutrients. Then, we'll compare plant versus animal protein. After that, we're looking at carbs, energy, and fiber. Fourth, we are demystifying dietary fats before zooming way in on fat molecules and cholesterol. And finally, we'll wrap it all up with the bottom line.
All right, Section 1. Meet the 3 macronutrients, the absolute foundation of human health. So, protein, carbs, and fats, they each play a totally distinct, totally irreplaceable cellular role. When we fall out of balance, our body's warning systems start firing off. Think about it. A lack of protein, that literally triggers muscle catabolism, meaning your body eats its own muscle. Lacking carbs brings on severe fatigue and that awful brain fog. And if you're lacking fat, you compromise vital vitamin absorption and you might literally feel cold all the time. But on the flip side, going overboard on any of these puts a huge strain on our biological systems. Excess protein processing can strain your kidneys, while excess carbs and fats are tied to profound insulin resistance and serious cardiovascular risks. It is just an incredible, intricate metabolic balancing act.
Moving right along to Section 2. Protein, plant versus animal, the building blocks of our muscles. Now, both animal and plant proteins are obviously fundamental for tissue repair, but the metabolic profiles are actually pretty different. Take animal protein, stuff like meat, fish, eggs, dairy. This gives you a complete, highly absorbable amino acid profile. Basically, your body can seamlessly extract what it needs and use it for direct muscle growth. Plant proteins like beans or tofu are a bit different. They often lack one or more of those essential amino acids. But here's the catch. By combining them or just eating a varied diet, you get a massive physiological advantage. Plant proteins bring the added bonus of being exceptionally rich in healthy fiber and antioxidants, and they have way less saturated fat. So it's a trade-off, but a really fascinating one.
Next up, Section 3. Carbs, energy, and fiber. Because, as you'll see, they are about so much more than just energy.
Okay, so carbohydrates actually operate on 2 entirely different biological tracks. Simple carbs, or sugars, give you this highly bioavailable immediate energy, fast fuel. But the hidden cost of eating too much of this is rapid, destabilizing blood glucose spikes. We've all felt that sugar crash, right? Complex carbs, specifically dietary fiber, operate completely differently. Instead of being converted directly into immediate energy, dietary fiber reaches your colon totally intact. And there, it ferments to produce short-chain fatty acids. This is absolutely crucial because it profoundly supports your gut microbiome, keeps you feeling full, regulates your blood sugar metabolism, and just keeps your whole digestive system healthy.
Let's get into Section 4. Demystifying dietary fats, because not all lipids are created equal. This is where the science gets really interesting.
Let's anchor the whole fat spectrum right in our everyday lives. We've basically got 3 main categories here. First, unsaturated fat. This is your olive oil, nuts, avocados. This represents the absolute optimal lipid profile for your heart and brain function. Then there's saturated fat. Think butter and fatty meats. The stuff that's solid at room temperature. These have a much more complicated relationship with your cardiovascular health. And finally, trans fat. You'll find this in fried foods and highly processed snacks. And let me tell you, these are incredibly harmful to human biology. But you might be wondering, why does olive oil protect your heart while a fried donut harms it? Well, to understand that, we really have to look closer.
Section 5. Fat molecules and cholesterol, under the microscope.
Now, what's really interesting here is that at a foundational molecular level, fats are simply made of chains of carbon atoms. It's like a giant microscopic puzzle. And the term saturation, it isn't just some marketing buzzword. It actually refers to exactly how many hydrogen atoms are chemically bonded to those carbon chains. The amount of attached hydrogen changes absolutely everything about how these fats physically behave, whether they're just sitting on your kitchen counter or actively circulating inside your cardiovascular system.
To really grasp a fat's impact, we need to do a quick recap on cholesterol. First up, HDL, or the good cholesterol. I want you to think of HDL as a microscopic scavenger roaming your bloodstream. It actively hunts down and picks up extra cholesterol in your blood, sweeping it away to the liver so it can be processed and removed. Biologically speaking, having a whole army of these microscopic scavengers is a prime indicator of great cardiovascular health.
But then, in stark contrast, we have LDL, the bad cholesterol.
When LDL levels creep up beyond normal parameters, this cholesterol doesn't get swept away. Instead, it oxidizes and literally embeds itself inside your arteries, leading to a buildup of hard plaque. Clinically, this is known as atherosclerosis, and it is no joke. This process creates dangerous blockages that can severely compromise your entire cardiovascular system.
And this brilliantly illustrates how molecular shape dictates your biological destiny. It's wild. Unsaturated fats actually have double bonds in their carbon chains, meaning they are missing some hydrogen atoms. This creates a kinked or bent shape. And because they're bent, they can't pack tightly together, which is exactly why they're liquid at room temperature, like your olive oil. Inside your body, these kinked fats actively increase your good HDL scavengers. Saturated fats, on the other hand, are fully saturated with hydrogen, no double bonds, so they are perfectly straight and rigid. They pack very tightly together, making them solid, like butter. Inside your body, these straight, rigid molecules directly elevate those dangerous LDL plaque builders.
And then we have the absolute worst offenders, trans fats. Honestly, trans fats are basically fake fats. They're created through an industrial process called partial hydrogenation. They artificially force hydrogen into liquid oils just to make them straight, solid, and shelf-stable. But here's the problem. Human biology literally has no idea what to do with this unnatural straight shape. They are a massive double whammy. They aggressively raise your bad LDL cholesterol while simultaneously killing off your good HDL scavengers. This triggers massive systemic inflammation. It's exactly why health organizations all over the globe have practically banned them from the food supply.
Which brings us to Section 6, the bottom line, putting it all together.
If you want a really easy framework for balancing these lipids in your own life, think of them as different grades of engine oil for your cellular machinery. Unsaturated fats, that's your premium fuel. They actually help keep your arteries clean and flexible. Saturated fats are more like a heavy fuel. They aren't instantly toxic, but you absolutely must use them sparingly so they don't gunk up the metabolic works. And trans fats? No way. They are literal industrial sludge in your cardiovascular system. Just stay away.
So, replacing a pat of butter with a splash of olive oil or a slice of avocado isn't just some passing diet trend. It's a literal molecular upgrade for your bloodstream. Now that you know the invisible chemistry of your food, what are you going to do about it? How will you swap your fats today to keep your cellular engine running beautifully?